In today's video, we're going to look at section 9-3, properties of logarithms. So the first property we're going to look at is the product property. For all positive numbers m, n, and b, where b is not equal to 1, the logarithm of base b of m times n. Now that means that m and n are both inside the logarithm function. So it becomes log base b of m plus log base b of n. So use log base 2 of 3 approximately equal to 1.5850 to approximate the value of log base 2 of 48. So what we can do is we can rewrite this and we can go log base 2 of 48. Now 48, if we do some prime factorization, just becomes 2 to the 4th times 3. Okay, so all I did was just write it in prime factorization. So I get log base 2 of 2 to the 4th times 3. Now I can apply my product property and say log base 2 of 2 to the 4th plus log base 2 of 3. All right, so now we know what log base 2 of 3 is. It's right there, so that's an easy substitution. The next problem is that log base 2 of 2 to the 4th. Well, that log base 2 of 2 to the 4th, if we set that equal to, say, x, and we rewrite this using our old properties, we can say 2 to the x is equal to 2 to the 4th, and then we end up getting x equals 4. Okay, so this whole thing is just 4. So we have 4 plus 1.580, and then we simplify and just get 5.5850. So I'm just using a bunch of different properties. Okay, so next one is the quotient property. It's the same as multiplication, but different. So same thing for all positive numbers m, n, and b, where b is not equal to 1, log base b of m divided by n. So again, m divided by n is inside the logarithm. We get log base b of m minus log base b of n. So use log base 3 of 5 is approximately 1.4650, and log base 3 of 20 is approximately 2.7268 to approximate log base 3 of 4. So here, log base 4 can be rewritten as 20 divided by 5. So I can just write log base 3 of 20 divided by 5. And now that will split into, using my division property, log base 3 of 20 minus log base 3 of 5. And now I just use my substitution. Log base 3 of 5 is 1.4650. Log base 3 of 20 is 2.7268. And then all I do is subtract them, and I get approximately 1.2618. All right, so again, just using properties and substitution. Okay, so we're going to skip that page. So the logarithm of a power is the product of the logarithm and the exponent. So this one is really nice. It makes it really easy. The power property of logarithms. For any real number p and positive numbers m and b, where b is not equal to 0, log base b of m to the p, so the exponent is only on the number inside the logarithm, you just take that exponent and it gets multiplied out front. So it becomes p times log base b of m. So log base 4 of 6 is approximately 1.2925, approximate the value of log base 4 of 36. So we get log base 4 of 36, which can be rewritten as log base 4 of 6 squared. So that 2 can be multiplied out front. So I end up with 2 times log base 4 of 6, and then log base 4 of 6 is approximately 1.2925, and I'm multiplying by 2 out front. Okay, and all I do is just grab my calculator to speed up my work, and I get approximately 2.585. And that's how we apply those properties. So now what we're going to do is we're going to take all those properties and solve some problems. So we have solve each equation. 3 times log base 5 of x minus log base 5 of 4 is equal to log base 5 of 16. Okay, so now what we can do is we can use our properties. This 3 is going to get multiplied back up. So we get log base 5 of x to the third minus log base 5 of 4 is equal to log base 5 of 16. And then we combine it once again using our division property. Log base 5 of x to the third over 4 is equal to log base 5 of 16. And now using our properties equality, we have x to the third over 4 is equal to 16. Multiply by 4 on both sides. We get x to the third is equal to 64. From here, we're going to take the cubed root to cancel out the cubed. So we get x is equal to 4. Okay. Next one. We have log base 4 of x plus log base 4 of x minus 6 is equal to 2. So right away, I can combine them. So I get log of x times x minus 6 is equal to 2. So I get the log of log base 4 of, now I'm going to FOIL x squared minus 6x is equal to 2. Now we use our properties and we can rewrite it as 4 squared is equal to x squared minus 6x. So x squared, or 4 squared, is just 16. So I'm going to subtract 16 from both sides. So I get x squared minus 6x minus 16 is equal to 0. This can be factored into x minus 8 times x plus 2, and that is equal to 0. Solve for both. We get x is equal to 8 or x is equal to negative 2. Well, looking at my original, if I plug in negative 2 to either one, remember we cannot put a negative into a logarithmic function, so negative 2 does not work. And then if I plug in 8, well, if I just do 8 minus 6 originally, 8 minus 6 and log base 4, that's just 2, so that still works. So my answer is x equals 8.